The next theorem is the maximum power transfer theorem, where the first slide is introduction. In this introduction, in any electrical circuit, the electrical energy is always transferred from source to load where the useful work is done. As the load size changes, there will be change in the maximum power transfer from source to load. This error can be reduced by using the maximum power transfer theorem, which equals the source internal resistance to the load resistance. Let's see how it is work. The next slide is circuit diagram. This diagram indicates all the components are connected in series with each other, includes sources, voltage sources. This diagram or circuit applicables to the maximum power transfer theorem because source resistance are equal in source resistance is equal in quantity with the load resistance, which indicates maximum power transfer from source to load. Okay, this circuit is applicable to the maximum power transfer theorem because source resistance is equals in the quantity with the load resistance, which indicates maximum power transfer from source to load. This is the basic or important concept of the maximum power transfer theorem. Okay, the next slide is the statement of what is the statement of maximum power transfer theorem, which is state that in linear bilateral network the maximum power is delivered to the load when the source internal resistance equals to the load resistance. If it is independent voltage source, then its internal resistance is series with the load resistance, or if it is independent current source, then it's a parallel internal resistance is connected in parallel with the load resistance. Okay, the circuit shows the series circuit which is applicable for the maximum power transfer theorem. Okay, the next concept or next formula for the maximum power transfer theorem, which is useful for solving the problem related to the maximum power transfer theorem, is P is equal to VTH square divided by 4 RTH. VTH square, this is the open circuit voltage, uh, which is open circuit parameter of the network, which is finding by opening the terminal AB, which is finding by opening the terminal of the network AB. Okay, divided by RTH, 4 RTH. RTH is the Thevenin equivalent resistance. This is the basic and important formula for solving the problem related to the maximum power transfer theorem. The practical application for this maximum power transfer theorem. The circuit shows series circuit which includes amplifier and speaker, which are connected in series with each other. Okay, this is the series circuit. We know that series circuit is applicable for the maximum power transfer theorem. Okay, what is the condition of maximum power transfer theorem? When maximum power transfer to the load, which includes internal resistance of the source, is equal to the load resistance. What is the internal resistance of the amplifier? Is 500 ohm. What is the load resistance of the speaker? Is 8 ohm. This quantity are mismatching with each other. Okay, that's why this circuit is not applicable for the maximum power transfer theorem. By matching these quantities means 500 ampere, 500 ohm for the amplifier and 500 ohm for the speaker, this matching quantity will leads to applicable for the maximum power transfer theorem means by matching this quantity, maximum power from transfer from source to load means source to speaker. This is the basic formula or basic concept of or basic application of maximum power transfer theorem.